Hello, welcome back. The puzzle today, it looks very simple, and at first sight you're gonna think it's easy. You just have to arrange the pole balls in the slots to make the equation true. So check here the numbers, and we have 3 slots. They need to add to 30. Try to find the right answer, and probably you will try a couple of combinations and you're gonna be upset because it's very hard and difficult to find the right answer. At the end of the lesson, we will solve this puzzle. Today we will work on chapter 3, graphs and functions, on section 3.7, graphing linear inequalities. The first objective is to graph linear inequalities. And a linear inequality in 2 variables will look like this. You have a x plus b y less than c. So the inequality sign here. This is an example. This is how it will look like. Instead of less than, we can have less than, we can have less than or equal to, you can have greater than, and you can have greater than or equal to. Any kind of inequality sign here. And this is the form of a linear inequality in 2 variables. A and B are not 0, are not both 0, and A, B, and C are real numbers. If you want to check if an ordered pair is a solution of the linear inequality, you plug in the value of x and y, and the result needs to be a true statement to say that the ordered pair is a solution, is included as in the set of this linear inequality. The step-by-step to graph. The first step is graph the boundary line found by replacing the inequality sign with an equal sign. And we will see this on the examples. Step number 2, choose a test point not on the boundary. You can choose a test point, or you can see the kind of inequality that you're working on, and we're also going to work on examples and see how to apply this step number 2. Step number 3, if a true statement is obtained in step number 2, shade the half plane that contains the test point. If a false statement is obtained shade the half plane that does not contain the test points. The first example is to graph x minus y greater than 3. Let's work the first step, which is to find the boundary. And the boundary is going to be this equation here, x minus y equals 3, right? We substitute the inequality sign by equals, and this is a line that we represent on the graph, and is the boundary of the area that represents this inequality here. For x minus y equals 3, we can make x equals 0, and then y equals negative 3, right? X equals 0, y equals negative 3. And we can make y equals 0, and x is going to be equals to 3. Important now is to check what kind of inequality we are working with. It's a greater than, right? If it's greater than, doesn't have an equal sign. If it doesn't have the equal sign here on the bottom, no, this one doesn't have the equal sign, we will represent the line dashed. That means the line needs to be dashed to represent that these points on the line do not belong to the solution set. So the line is going to be dashed. This is the point. Now Now, according to the procedure, you have to find a test point. The test point usually can be 0 and 0. If this test point produces a true statement when you plug into the inequality, then you can say yes, this area is the area that belongs. The area is the one that we will select as the representation of the solution. Another way of looking at this is to check the kind of inequality as well. We are looking at a greater than sign. Well, let's work on the test point first. We are working on the test point first. So, and this is the position, the place of the testing points, and we will plug in here on the inequality. X equals 0 minus y equals 0 greater than 3. What do you think? Is this right or wrong? Is this true or false? This makes 0 greater than 3, and this is, of course, false, right? That means the area that we're looking for is the one opposite to the testing points. So the area that you're looking for, let me find another color here. Maybe this light green is this area opposite to the one of the testing point, and this is going to be the solution, the area that represents the solution set. Okay, because you tested, and this turned into be false statement. So this point here is not in the solution set. Let's try another example. Graph x minus 4y less or equal than 4. So again, the first step is to draw the boundary, the line that represents the boundary, and the line is going to be x minus 4y equals 4. Make x equals 0, you're going to find y equals -1, so x equals 0, y equals -1. Make y equals 0, you will find x equals 4. So y equals 0, x equals 4. The line will go through these 2 points. Check the kind of inequality that you have here, and there's an equal sign here on the bottom, right? There's an equal sign. The line is going to be solid because the line is included on the set. All the points on the line are part of the solution, and that's the reason we represent the line as a solid line. The boundary is a solid line. Next step, choose a testing point. If possible, if it's not on the line, you always choose, my suggestion, you always choose 0 and 0 as a testing point, because usually it's easier to calculate. And that's what you're going to do here. Plugging x equals 0, minus 4 times 0, y equals 0, then you're going to have to plug in this into the inequality. The inequality is less or equal than 4. Okay? Let's check if this is a true statement that makes 0 less or equal than 4. And this is, we write with green, this is true. Yes, this is true. The consequence is the area that where this point is, the same area of this point, the same half of the graph is going to be the solution set. So we will shade this area here same area of the point, and we came to the conclusion that the point is included, is part of the solution set. Okay, so all this here is the solution set. And remember the boundary is a solid line because yes, the boundary is included in the solution set. Nice. Now let's work on another example. We have here graph 3x plus 5y less or equal to -2. Find the first step, find the boundary. The boundary is 3x plus 5y equals the -2. We can make x equals 0 and find y, and y equals 0 and find x. But I think it would be not good because we're going to work with fractions. Probably if we work with x equals 1, it's going to be better. Let's try. If x equals 1, we're going to have y, 5y equals -5, y equals -1. And if we make y equals 1, we will have 3x and 5y go to the other side, -7y, x equals -7/3. Yeah, it's a kind of it's a workable. We can work with this. -2.3 approximately. -2.3. So we can find the points. X equals 1, y equals -1, right here. And y equals 1, x -2/2.3, approximately. So y equals 1, x -2.3, somewhere in here. Now we connect the points to find the boundary, the line. Keep in mind that this is a less than or equal to. That means we will have a solid line as a boundary. We will have a solid line as the boundary because it represents that the boundary is included in the solution set. When you have the equal sign here in the inequality, then we draw the boundary as a solid line. Now we can test if x equals 0, y equals 0, because it's not on the line. It's close to the line, but it's not on the line. Make here 3 times 0 plus 5 times 0. Check if it is less or equal to -2. Let's check. 3 times 0, 0. 5 times 0, 0. Less or equal to -2. What do you think? This is going to be false, right? Because -2 is less than 0. That means we will shade the opposite area, which is this one. The opposite area is this one here, opposite to the testing point. We used x equals 0, y equals 0 as testing point. It turns out to produce a false statement. That means it's the opposite area. The solution is the opposite area. This is going to be the solution. And we have yet another example. 3x less than 15. Well, the same thing you have to do. We have to find the boundary and make 3x equals 15. And the boundary is going to be x equals 5, right? This is the boundary. find x equals 5 is this point here. Oops. This is x equals 5. And we don't have on the inequality, there's no equal sign, only less than. And we will represent the boundary dashed. This line here does not belong to the solution sets. Try the testing point. We can still work with x equals 0, y equals 0, and make here 3 times 0 is less than 15. Question, yes, is this true or is this false? True. This is a true statement. Yes. The 0 is less than 15. As a result, we will shade everything here on the area, the same area where the point is, where the testing point is. So this is the solution set, all this area here, which where the testing point is inside, is included. Okay. This is our solution for the example. Yet another example. Now we have to graph y less than 2. Y less than 2. Boundary is going to be y equals 2. And y equals 2 is right here. This is the point y equals 2. Check the inequality, and we don't have an equal sign. It's just less than. It's not less than or equal to. The conclusion is yes, the boundary is dashed. We don't have the equal sign. It means the boundary is going to be dashed. The boundary does not belong to the solution sets. Now let's apply the testing point. We can still use x equals 0, y equals 0. Is 0 less than 2? True or false? Answer the question. Is this true? Is this false? True. Yes, 0 is less than 2. That means the point is included in this solution set, and the area will be the same area where the point is. This area here below the line. Okay, this is our solution set. All the points that are included in this area. And remember, the boundary is out. The boundary is not in the solution set because this doesn't have an equal sign on this inequality. One more example. Let's work on this. Find the boundary, and we have here y. Let's make y equals 1 over 4 x minus 3. This equation here is in the slope-intercept form. That means slope equals 1 over 4, and the y-intercept is negative 3. That's easy. That's a good thing because it's easier to plot. We just find the y-intercept negative 3 right here, and now we're going to run. The slope is rise over run. We have to run 4, 1, 2, 3, 4, run, and we rise 1. Rise 1, the next point, the second point that we're going to use to find the line is this one right here. See, rise over run. Rise is on the vertical and run on the horizontal. My question to you, is this line going to be dashed or solids. Check the inequality. Does it have an equal sign on it? If yes, it's going to be solid. If you find an equal sign on the inequality, no questions. Yes, it's solid. That means the boundary is included in the solution set. All the points here on the boundary are included in the solution sets. And our friend here, the point, the origin, x equals 0, y equals 0, can we use it to check as a testing point? Yes, as long as it is not on the line, on the boundary, we can use. So make y equals 0, less than or equal, less than or equal to 1/4 times 0, x equals 0, minus 3. The result here is, after simplifying, 0 less than or equal to -3. What do you think about it? Is this true? Is this false? Is 0 less or equal than -3? Of course, it's false. This is false, right? 0 is more than -3. And we will shade everything that's underneath. It's in the opposite side, the opposite area that does not contain the testing points. Right? Helpful hints. When graphing an inequality, make sure the test point is substituted into the original inequality. And this is very important. At the very beginning, the first one. Also note that although all of our examples allowed us to select 0, x equals 0, y equals 0, sometimes it's not going to be possible. If the boundary line contains the point x equals 0, y equals 0, you need to select another point. Okay. Next objective, number 2, graphing intersections or unions of two linear inequalities. Check this out. Now we're going to have two inequalities. We were kind of having trouble working with just one. Now we're going to have two inequalities to graph here on the same rectangular coordinate system. Let's work step by step here. Take it easy and let's move here working on the first one, and we have x less than or equal to 2 to find the first boundary. First boundary, x equals 2. X equals 2 is here. Check it out. Is this going to be a dashed or solid? What do you think? Dashed or solid? Yes, it's going to be solid, right? You have the equal sign here. Means solid. Solid line. Now apply the testing point. Can we apply? Yes, the testing point is right here. It's not on the boundary. So try. Let's try the testing point. 0 is less or equal than 2. What do you think? This is a true or a false statement? I can say yes, it is true statement. 0 is less than 2. This is a true statement. We can shade the whole thing here, this whole area right here can be shaded, including the testing point, because it produces a true statement, right? Shade everything on the area where you can find the testing point, same area. Now let's go to the next one, next inequality. And the next inequality that we have here is y greater than or equal to x plus 1. the boundary y equals to x plus 1, right? And the boundary is going to be, let me use a different color, maybe an orange, yes, orange. If y equals 0, we will have x equals -1, so y equals 0, x equals -1, this point right here. And if x equals 0, y equals 1. X equals 0, y equals 1. Nice. What about the boundary? Solid or dashed? What do you think? Solid or dashed? Yes, solid. We have the equal sign here, right? Solid. Solid boundary. And now we have to select the area. Above the boundary, below the boundary. Test. Try testing. And what about the testing point? Is here. Cool. We can use the testing point 0 and x equals 0, y equals 0. 0 greater or equal, and 0 plus 1. What do you think? Is 0 greater or equal than 1? True or false? What do you think? False, right? This is false. That means we have to shade the other area, the opposite area. And we will shade the opposite area. Nice. Oops. And now just take some distance, look at the graph, and think about, we are talking about intersection. We want to find intersection. Intersection is and. That means we need to find the area that have the colors blue and the color orange. Both colors. The intersection is and. So we need the area with color blue and color orange. And I will, let me see here, a new color, green. Let's make green. The area is going to be this, well, we include this boundary all the way up to here. And now this boundary here, see? The intersection needs to have both colors, blue and orange. And the shade is this one, again, that have both colors, blue and orange. And now we have so many colors here in this graph. Check if you are understanding, if you agree. And now the solution set is the area that we shaded as green. We can even erase the other ones if you can, if you want. You can erase the other colors and keep only, yes, keep only the area that is the intersection. Now let's work on the last example. Graph the union of x plus 2y less or equal than 4, or y greater than or equal than -1. Okay, the first one that we will work is x plus 2y less than or equal to 4. The boundary is x plus 2y equals to 4. Find the points. We need 2 points, at least 2 points. Make x equals 0, then y equals 2. X equals 0, y equals 2. And make y equals 0, x equals 4. Y equals 0, x equals 4. This is the first one. Is this going to be a solid or dashed. And yes, check this. The inequality has an equal sign underneath. So it is a solid line. Definitely a solid line. Now apply the testing points. The testing point, x equals 0, y equals 0. 0 plus 2 times 0 is less than or equal to 4. Let's check if this is true or false. True or false? What do you think? True or false? Yes, this is true. And we can shade everything in the area that have the same testing point, the same area of the testing point. These ones. Remember, the testing point is x equals 0, y equals 0. This is one the testing point that we used here. Now let's find the other area that we're looking for. This y is greater than or equal to -1. The boundary is y equals -1. Y equals -1 is right here. And do we have an equal sign? Yes, that means solid line. Solid line. Right? The union, we are working here, and then first let's try the testing point, and we can still use x equals 0 and y equals 0. So 0 is greater than or equal to -1. This is the question. Is this true? Is this false? What do you think? Yes or no? And we can say yes, of course. 0 is greater than -1. 0 is greater than any negative number. True. Again, we will shade the area with the testing point. It's going to be orange. And let me shade like this. Everything above the line is okay, is included. Well, this is very interesting. Have a look and give a few steps back and look at the graph, because we are trying to find union, right? We are trying to find union. Or means union. We need all the areas that have one color or another color. If it has any color, that's nice. That's what I'm looking for. And let me zoom out a little bit, because I need you to see something here. Check this out. This line will keep going like this. This other line will keep going like this. And the shade is going on and on. And I will represent the union with this red color, okay? The union is the area that have one color or another color. So this, yes, this is all included, because these have both colors. And this on the bottom, yes, is included because have at least one of the colors. So all this area in red is included. We check it out. This one here is not included. Doesn't have any color at all. So this area, let me represent here, this is not included at all. This is the union. Okay? that's it. We finish section 3.7. Now we can try to solve our puzzle. What do you think? Did you come up with a solution? Let me clear this. And it's tricky. This one is tricky. If you like to play pool or snooker or billiards, maybe you know the balls. They have colors, right? And if you check the numbers here, they are all odd. That means you're never going to add 3 numbers and have 3 odd numbers and have an even number, right? This is impossible. But there's a trick. Check this out. The green ball on billiard, on pool, is the ball of number 6. And here the ball is upside down. And you have to notice that. If you need to arrange to make a true equation, you can turn around the ball and use in the right position. And so you can add 6 plus 11 plus 13, and you will have 30 as a solution. The answer here is 6 plus, let me write here, 6 plus 11 plus 13 is the right answer. Okay, thank you for watching this video. And yes, as usual, I hope to see you on the next section.